Josh, what do you think is one of the most overlooked fluid power components?
That's easy. High pressure hydraulic hose. And yet is one of the most important components of a system, especially in any machine with actuators attached to moving segments.
But hose is such a simple component, right?
At first glance, yes. But with newer synthetic materials like PTFE, also known as Teflon, and butynitrile, hydraulic hose has a lot of flexibility to offer. This flexibility allows the hose to absorb vibration and noise, which can be troublesome with pipe and tube assemblies. Hose assemblies are also easier to manufacture than hard plumbing. They're easier to manufacture and install and less expensive.
And that rubber you mentioned won't rust like most hard plumbing, right? So other than the rubber carcass, how is hydraulic hose constructed?
The construction technique and material of hydraulic hose differs based on the intended application. The majority of hydraulic machines are not exotic, however, and typically your standard 100R1 or 100R2, also known as 1-wire and 2-wire respectively, our hoses are all that's required. Hydraulic hose is usually rated from 1,000 to 6,000 psi or more. They use a 3-layer construction, an inner tube, a reinforcement layer, and then the outer cover.
Are all hoses created equal when it comes to the fluid type that you're using?
I'm glad you asked that. The tube construction material is dictated partly by the fluid being used in the hydraulic system. For example, nitrile rubber or rubber is fantastic for petroleum-based hydraulic oil, but would not be compatible with synthetic fluids such as a phosphate ester, which requires Viton or Teflon. Special attention should be paid to the chemical compatibility of the outer cover as well. There could be ambient conditions and chemicals that are incompatible with the cover material, which is commonly nitrile. Cover material can be made from neoprene, PVC, nitrile or non-rubber woven textiles, which is the old school way of doing it.
What about temperatures? How do those rubber materials stand up to those extreme temperatures you might see in mobile equipment, for example?
Standard hose construction allows for anything between, say, 40 and 202 degrees Fahrenheit. Such as with common combination of nitrile tube or neoprene cover, but special formulations of these polymers are required for colder conditions. Colder weather polymers need to be highly malleable to prevent cracking and subsequent hose failure. At the other extreme, ambient operating heat can cause premature hose failure due to softened tube and cover. For conditions anywhere above, say, 400 degrees Fahrenheit, Teflon can be used for the tube and then wrapped with a stainless steel cover. The downside of Teflon hose is that it's not terribly flexible and has a large bend radius.
Okay, so let's go back to the cover then. What else does that extra layer of material guard against?
So a common failure of hydraulic hose is a result of abrasion. So the special attention should be paid to the cover construction material. While proper mounting and clamping can help, friction is not always avoidable. In these instances, special hose construction with an abrasion-resistant cover is a solid choice, and is the use of a protective hose wrap, for example. I should point out that old school textile hose cover, although dubious looking, is actually superior to most neoprene rubbers when it comes to abrasion resistance.
Okay, so now we've talked about the outside. Let's talk about the inside of the hose.
The central defining criteria most people associate with hydraulic hose is its pressure holding capacity, and it owes that capacity to the reinforcement layer. The reinforcement layer is tightly wound upon the tube with a spiral winding or braiding machine. The cover is then applied and you have a complete hose. Steel wire is, by and large, the most popular choice for hose reinforcement layer and is either cross-braid or spiral wound. The cross-braided wire has alternating rows of perpendicular wire woven in opposite directions around the tube, so like many dancing children around a maypole. The braided steel hose comes in 1 or 2 layers and is usually separated by another layer of rubber when 2 layers are used.
So what are the advantages of braided versus spiral hose?
Braided hose is the most popular type of hydraulic hose. It offers excellent flexibility for its strength, and most manufacturers make high-flex braided hose with half the bend radius of its standard cousin. The 2 types of spiral wound hydraulic hose, the helically coiled hose is a mild reinforcement used to increase pressure capacity, but is typically limited to suction lines where little or no pressure exists. Sometimes it's used on return lines where no pressure spikes are of concern. However, the tightly wound spiral layers for the hydraulic hose are used on ultra-high performance, high-pressure systems. 4 layers of high-tensile steel wire are laid directly on top of each other, perpendicular to each subsequent layer. The 4-layer spiral wound hydraulic hose is extremely strong, is common in high-pressure, large-diameter hose assemblies. However, these designs are usually less flexible as they feature a rigid, multi-layer construction.
Well, thanks for all those tips, Josh. And in the meantime, visit www.fluidpowerworld.com for more videos, and thanks for watching.